Hi friends, in the previous videos we have discussed about introduction to signals and systems and classification of signals. Again this classification has divided into different types of signals. Now let us see problems on periodic and non-periodic signals. First, what is the condition for periodic signal? For a signal to be periodic, x of t must be equal to x of t plus capital T, where capital T is a constant representing the period. So let us see the first problem. Here it is given that show that the complex signal which is exponential, it means it is a complex exponential signal, x of t is equals to e power j omega naught t is periodic with period 2 pi by omega naught. It is given that x of t is equals to e power j omega naught t is a periodic function, periodic signal. So the period of the signal is 2 pi by omega naught. We have to prove that. So the condition for periodic signal is x of t is equals to x of t plus t. We need to remember this. So given x of t is equals to e power j omega naught t. X of t is periodic only when x of t is equals to x of t plus t. Therefore x of t plus t becomes e power j omega naught t plus capital T, which implies e power j omega naught t plus into e power j omega naught small t. We know that x of t is equals to x of t plus capital T. So substitute these values. E power j omega naught t is equals to e power j omega naught t into e power j omega naught capital T. These two get cancelled. So e power j omega naught capital T is equals to 1. The value is equals to 1 when e power j theta is nothing but cos theta plus j sin theta. So from this equation we can write as cos omega naught t plus j sin omega naught t is equals to 1. This total value is equal to 1 when omega naught t is equals to 2 pi by n. When omega naught t is equals to 2n pi, which implies t is equals to 2n pi by omega naught. But in the question it is given that period is equals to 2 pi by omega naught. At n is equals to 1, it becomes t is equals to 2 pi by omega naught. At n is equals to 1. This is called fundamental period. Once again I will explain you the problem. For a signal to be periodic, the condition is x of t is equals to x of t plus t. Here x of t is given as e power j omega naught t. So we know that x of t is equals to x of t plus t. Substitute that value, x of t plus t is equals to e power j omega naught t plus capital T. Then it is e power j omega naught t into e power j omega naught capital T. So if you equate x of t and x of t plus t, we will get e power j omega naught t capital T is equal to 1. We know that e power j theta is cos theta plus j sin theta. In the same way, e power j omega naught t is cos omega t plus omega naught t plus j sin omega naught t, which is equal to 1. The value is equal to 1 if and only if omega naught t is equals to 2n pi. So t is equals to 2n pi by omega naught. Here in the question it is given that period is 2 pi by omega naught. So t is equals to 2 pi by omega naught if n is equals to 1. At n is equals to 1, the period is 2 pi by omega naught and it is called fundamental period. Sinusoidal signal x of t is equals to sine of omega naught t plus theta is periodic with period 2 pi by omega naught. Here also it is given that the signal is periodic. Of course we know that every sinusoidal signal is periodic signal. And here period also given, we have to just prove it. So let us write first what is given in the problem. Given x of t is equals to sine of omega naught t plus theta. This x of t will be periodic if x of t plus t is equals to x of t. By this we can write x of t plus t is equals to sine of omega naught t plus omega naught capital T plus theta. Sine of omega naught t plus theta plus omega naught t. We know that this value must be equal to x of t. What is x of t? Sine of omega naught t plus theta. When will be the value is equal? If omega naught capital T is equals to 0. At what values omega naught capital T is 0? At 2n pi. Omega naught t is equals to 2n pi. Therefore t is equals to 2n pi by omega naught. If n is equals to 1, t is equals to 2 pi by omega naught, which is fundamental period. This is about the second problem. Once again I will tell you. Given x of t is sine omega naught t plus theta. Generally all sinusoidal signals are periodic signals. X of t will be periodic if x of t plus capital T is equals to x of t. So x of t plus t we can write it as, in place of t we have to replace it with t plus capital T. So it becomes sine of omega naught t plus omega naught capital T plus theta. We know that omega naught t plus theta, sine of omega naught t plus theta is equals to x of t. This value should be equal to this value, so that omega naught t must be equal to 2n pi. Then only these two are equal. So t is equals to 2n pi by omega naught. If n is equal, they are periodic, then we need to find out the fundamental period. First question is sine 12 pi by 12 pi t. We already know that all sinusoidal signals are periodic. So let us see, we already know all sinusoidal signals are periodic. Given x of t is equals to sine 12 pi t. Since x of t is a sinusoidal signal, it is periodic. By comparing x of t with sine omega t, if we compare x of t with sine omega t, then omega is equals to 12 pi. Generally we know that t is equals to 2 pi by omega. Therefore omega is equals to 2 pi by t. 2 pi by t is equals to 12 pi, which implies t is equals to 1 by 6. Therefore the period is 1 by 6 seconds. We know that sine signal is a periodic signal. Therefore we can say that it is periodic. And now we have to find out the fundamental period. So compare the signal sine 12 pi t with sine omega t. Then the omega value is 12 pi. We know that t is equals to 2 pi by omega. Then omega is equals to 2 pi by t. In place of omega substitute 12 pi. 12 pi is equals to 2 pi by t. Then it is 1 by 6 seconds t is equals to. Let us see next problem. In the next problem it is given x of t is equals to e power j 4 pi t. X of t is complex exponential signal, so it is also periodic. It is a complex exponential signal, so it is periodic. By comparing x of t is equals to e power j 4 pi t with e power j omega t, compare x of t with, since it is periodic signal, compare it with e power j omega t. Then value of omega is 4 pi. We already know that t is equals to 2 pi by omega. Then omega is equals to 2 pi by t, which implies 2 pi by t is equals to 4 pi. 2 times. Therefore, t is equals to 1 by 2. Therefore, fundamental period t is equals to 1 by 2. We know that e power j 4 pi by t, 4 pi t, it is a complex exponential signal. Complex exponential signals are also periodic signals. So we need to compare it with e power j omega t. Then we will get the value and t is equals to 1 by 2. Let us see next problem. First let us consider x of t is equals to x1 of t plus x2 of t. Since it is given here, two signals are given, summation of two signals. x1 of t is cos 2t. Compare it with cos omega t, therefore cos omega 1t, therefore omega 1 is equals to 2. Omega 1 is equals to 2 pi by t1, which is equals to 2. t1 is equals to pi. Let us see second signal. x2 of t is equals to sine root 3t. Omega 2t, compare it with sine omega 2t. Omega 2 is equals to root 3. 2 pi by t2 is equals to root 3. t2 is equals to 2 pi by root 3. So, if two signal summation is given, after finding the fundamental periods of individual signals, we have to take the ratio as t1 by t2 is equals to pi by 2 pi by root 3, which is equals to root 3 by 2. If the ratio is an integer, then the signals are periodic. If the ratio is not an integer, then the signals are not periodic. So it is not a ratio of two integers, not a ratio of two integers. So it is non-periodic. Once again I will repeat this question. Here the signal cos 2t plus sine root 3t. Here it is a summation of two individual signals. Actually these two signals are periodic if we calculate individually, but we don't know when we calculate the summation whether the signal is periodic or non-periodic. So first of all we need to calculate the individual periods of two signals. x1 of t is equals to cos 2t. x of t is equals to x1 of t plus x2 of t. Let us consider x1 of t is equals to cos 2t. Compare this with cos omega 1t. Since we are taking omega 1 because here there are two functions cos 2t and sine root 3t. To avoid confusion, we are taking it as omega 1. Compare it with cos omega 1t. Then omega 1 value is 2. We know that omega is equals to 2 pi by t. Here omega 1 is equals to 2 pi by t1. Therefore t1 is equals to pi. In the same way, calculate t2. Now we need to find out the ratio of two fundamental periods of two signals. If the ratio becomes an integer, if the ratio is two integers, then the signal is periodic. Otherwise, it is non-periodic. In the above question, we get the answer is root 3 by 2. It is not the ratio of two integers, so it is non-periodic. Let us see the next problem. Sine of 0.02 pi n. Here given x, it is a discrete time signal. If you observe here, it is n. So it is discrete time signal. Therefore, given x of n is equals to sine of 0.02 pi n. This is also a sinusoidal signal, so it is periodic. Since it is a sinusoidal signal, it is periodic. Now we have to find out the period. Compare this signal with sine omega n. Then omega value is 0.02 pi. We know that omega is equals to 2 pi by n, which is equals to 0.02 pi. For a continuous time signal, x of t is equals to x of t plus capital T. For a discrete time signal, x of n is equals to x of n plus capital N. Therefore, omega is equals to 2 pi by capital N. Now, to 0.01 pi. N is equals to 1 by 100. It is the ratio of two integers. So, the signal is periodic and the period is 1 by 100. Once again I will tell this. It is a discrete time signal since it is given sine of 0.02 pi n. X of n is equals to sine of 0.02 pi n. It is a sinusoidal signal, so it is periodic. Omega, compare it with sine omega n. Omega is equals to 0.02 pi. For a continuous time signal, omega is equals to 2 pi by capital T, and for a discrete time signal, omega is equals to 2 pi by capital N. 2 pi by capital N is equals to 0.02 pi. Then n is equals to 1 by 100. This is the ratio of two integers. So the signal is periodic and the period is 1 by 100. This is about the problems on periodic and non-periodic signals. Thanks for watching the video.